Hi there, folks. Today we're looking at solving equations with variables on both sides. And really, this is the same as what we've been doing, except we have to kind of get the variables in one spot first, okay? And so there's two ways you can think about this. So if there's variables on both sides, we want to gather all the variables to one side of the equation and then solve, all right? You could also think of it this way as instead of getting the variables on one side, getting rid of the variables from one side, okay? Both of those things give you the same result. I will say that getting rid of a variable is more in the spirit of what we're doing in terms of solving equations, so that might make more sense to you, all right? So the only way to do that is by adding or subtracting the variable from one side, okay? That's the way we get rid of it, and that's the way we move it to the other side. So keep in mind, this shall be done by adding or subtracting, okay? For example, if I look at this first one, notice I have a variable on each side. I have the negative 8x on one side. I have the 4x on the other side. I can't combine them because, remember, they have to be on the same side of the equation in order to combine them. So what I want to do is I want to get them on the same side. And I can get them on the same side by either subtracting the 4x, because that's the way to make this thing move to the other side, or adding the 8x. And again, if you want to think of it this way, think about getting rid of one of those variables. In other words, how do I get rid of a minus 8x? I do the opposite, which is add 8x. Or how would I get rid of a 4x? I would subtract 4x, okay? And a rule of thumb here, just always try to get rid of the smaller value, all right? Essentially, think of it as moving something. When I move things, if I have the choice of moving two things, I'm going to choose to move the smaller thing because that's easier, all right? And it's the same way with numbers. When you look at a minus 8 versus a positive 4 in terms of the x values, negative 8 is smaller, so that's the one I want to get rid of. So here, to get rid of a minus 8x, I'm going to add 8x. And whatever I do to one side, I have to do the other side. And essentially, the net result here, the negative 8x plus the 8x is a 0, so that cancels out, and I'm left with the 7. Now that 8x is essentially on the other side as a plus 8x. Now I can combine those, the 4x and the 8x, and get myself a 12x. Okay? Now this is just like the equations we've been solving. I have to undo addition and subtraction first. Remember, working backwards through order of operations. To undo subtracting 17, I have to do the opposite, which is add 17. Whatever I do to one side, I have to do to the other side. And so over here, 7 plus 17 is a 24. Over here, I have a 12x. And now to undo multiplying by a 12, I have to divide by the 12. That's the opposite operation. So I end up here with a 2 and here with an x. And it's usually a little awkward to leave it like that. Usually we write it as x equals 2 instead of 2 equals x. Not that it really matters that much, okay? If I look at the next one, notice variables on each side, but I can't just start subtracting them because one of those variables is trapped in parentheses, okay? So we have to find a way to get rid of those parentheses first, and the way that we do that is using our distributive property. Because remember, when we distribute, the parentheses are no longer there. So let's distribute that 1/4. Again, don't be scared of the 1/4. Remember, a 1/4 is just a divided by 4. A fraction bar is a division sign. So in other words, 16 divided by 4 is a 4. 60 divided by 4 is a 15. And now I have to get the variables together. So I have to get rid of either the 9x or the 4x. Get rid of the smaller one. Let's get rid of that 4x. To get rid of a 4x, I have to subtract 4x. Whatever I do to one side, I have to do the other side. I can combine the 9x and the minus 4x, which is a 5x. Over here, those cancel out, so I just get the 15. Now I'm back to what I've always been doing. I undo the subtraction by adding 5 to each side. I undo multiplication by dividing, so I divide each side by 5. And let me write that up here. I ran out of space, so x equals a 4, and that's it. Okay? So we're still doing all the same things that we were doing. We're simplifying and then solving. But in the process of simplifying, once I get to that solve it part, if the variables are on different sides, I just have to get rid of the one of them so that they combine. Okay? So I can get them on the same side. If I look at this one, again, following the same things that we've always done, let's simplify and then solve. Let's simplify by using our distributive property. So here I distribute the 3. So let's see, that gives me a 3x equals 3x plus 12. And now I have variables on different sides. I can't combine them, so I have to get rid of one of them. I'm going to get rid of the 3x. So to get rid of a 3x, I subtract 3x. And whenever I do to one side, I have to do the other side. And students get a little hung up here because they're like, wait a minute, 3x minus 3x, everything goes away. Well, what number are you left with? And everything is gone. 0. Okay? 0 is a number 2, and there's nothing wrong with getting 0 over here. 3x minus 3x is a 0. That's fine. Over here, 3x minus 3x is also a 0, but there happens to be a plus 12 there. So I get a 12. And now I have a very strange situation. It says 12 equals 0. And if you think 12 equals 0, we might have to go back and review some things. If you're looking at that thinking, wait a minute, 12 doesn't equal 0, then you're absolutely right. 12 does not equal 0. And what that means when I'm solving an equation and all the variables end up going away and I'm left with a false statement, it means that there is no solution for this. And here's the symbol for no solution. It's a little 0 with a slash through it. That's the null set symbol, which means the set is empty. So the set of solutions is empty, which means there are no solutions. Okay, so we use that for no solution. If you literally write the words no solution, that is fine. Okay, but understand that basically there is no value for x that will make this equation true. Okay. If I look at the next one, again, simplify and then solve, I'm going to simplify by using my distributive property. That gives me a 2x plus 8, the minus 4x. Over here, I have to use my distributive property. That gives me a 3x and a minus 3. And now before we try getting the variables on the same side, if you look, 2 of the variables are already on the same side. And if the variables are already on the same side, I can combine them, all right? The only reason I've been doing what I've been doing in terms of subtracting the variable or adding the variable and moving it and getting rid of it is because they were on different sides. When they're on the same side, I can just simplify by combining like terms. So if I combine these, that's a negative 2x. I still have the plus 8, still equals a 3x minus 3. And now the variables are on different sides, so now I have to move them. So I'm going to get rid of the smaller value. I'm going to get rid of the minus 2x. To get rid of a minus 2x, I have to add 2x. And so over here, I'm left with just the 8. Over here, 3x plus 2x is a 5x. And now I can solve the way that I've been solving. I undo the operations, working backwards through order of operations. So I undo that subtraction by adding the 3 to each side. And now I undo this multiplication with division. And again, I can just leave that. It says 11 over 5. I'm going to leave it as 11 over 5. And let me rewrite it the other way. X equals 11 over 5. Oh, good old improper fractions. Don't be scared of them. Okay? And then if I look at this last one, once again, using my distributive property to simplify, so I'm going to distribute the... Sorry, I've been distributing using that green. Okay, we don't want to stop now. It felt good to do that, right? So I distribute that 2. That gives me a 2x plus 6. Over here, I have to distribute the 3. Oh, my computer's having a little trouble allowing me to select the markers I want. So that's a 3x plus 6 minus x. And then once again, notice, not all the variables are on different sides. 2 of the variables, the 3x and the minus x, are already on the same side. When things are on the same side, I can combine the like terms. So let's do that combining first. Notice, because I'm still simplifying before I solve, so I get a 2x plus 6. And now the variables are on different sides, so I'm going to move one of those 2x's. To get rid of the 2x, I subtract 2x from each side. So I'm going to subtract this 2x from each side. Over here, the 2x and the minus 2x cancel, so I'm just left with a 6. Over here, the 2x and the minus 2x cancel, so I'm just left with a 6. So I end up with this statement of 6 equals 6. And this is similar to what happened in the example above here. All the variables went away, but I had 0 equals 12, which was a false statement. Here, all the variables go away, and it gives me 6 equals 6, which is a true statement. The difference is when it's a false statement, it was no solution. It means nothing could possibly work. When it's a true statement, it means everything that I plug in for x will work, okay? It doesn't matter what x is. I will eventually get something like 6 equals 6. It will be the same thing no matter what. So the way we say that is if every number can be used, we're going to say it's all real numbers. And you can write out the words all real numbers if you would like. Or if you're like me, there's a fancy symbol for all real numbers. Looks like this. It's a capital R with a little bar on that R. Okay? So all real numbers, or just write out all real numbers. But that's if we get a true statement. Okay? False statement, no solution. True statement, all real numbers. Okay? But other than that, we're doing the same things. Simplify by distributing. Simplify by combining like terms if they're on the same side. And then if variables are on different sides, get rid of one of them. Add one of them or subtract one of them to move it so that we can combine those variables and then solve the way we've always solved, working backwards sort of operations, undoing operations as we go. Okay?